on pairs of lines and angles. We are only doing pairs of lines for this test. Pairs of angles will be for the next one. First word is parallel lines. So go ahead and write parallel lines are coplanar and they do not intersect. So they are coplanar and do not intersect. Coplanar and do not intersect. What does coplanar mean? Points on the same plane, or just on the same plane. So here's what we're looking at. We've got these lines and we've got these lines. Remember that in geometry you can't assume things. They have to be written out for you. So what would have to be written in order for me to know that this was a right angle? Your box. It's okay. If two lines were congruent, what would be marked on them? The dash, right? So in order for two lines to be parallel, what you're going to have are arrows. So go ahead and draw these arrows on line L and M. And I am going to tell you what to draw on the other two. So on L and M, you're just drawing like a little arrow, like a carrot. On this other set of lines, A, B, and C, D, yes, it could look like this, but I don't want you to draw that. It can look like that. Remember that the amount of arrows, so there's two on these, that means they're parallel to each other. These have one arrow. They're parallel to each other. But what you'll mostly see in your textbook is actually not an arrow. It would be a triangle. So I want you to draw a triangle on line AB and line CD. So two triangles. And in your textbook, they'll actually be red. But obviously your quizzes and tests are in black and white. So this would indicate that they're parallel. Otherwise, you can't say, well, they look like they're parallel. Okay? There is a symbol for parallel. And it is two straight lines. I call them twin towers because they were parallel. And they're, just two straight lines like that. It means it's parallel to. So if we were to say that these two lines were parallel, how do we name a line that only has a lowercase letter? Line. So you're going to write this. Line L is parallel to line M. Line L is parallel to line M, which you're going to write under these two lines. The second set, would I use the word line? I would not. What's the difference between the second set of parallel lines and the first set? What does this one have? Points, and this one did not. So whenever you have points on the line, you can use 2 points to name the line. So to name this first one, we could say AB. What would these symbols above it look like? A line with 2 arrows. So AB, line AB, is parallel to line CD. I'm going to hit next. It's going to pop up. Ta-da. Perfect. What I want you to highlight is the term and the definition. We use this word for the rest of geometry. And to drive it home a little bit, we're going to look at the west side of Jacksonville.
Oh.
Ta-da! We are going to find parallel lines. Okay, so we're going to list off streets. I know if you're further in the back, it's harder to read names. Do the best that you can. Who can name one set of parallel lines? What you got? Yep, and Gordine. That's fine. They're parallel. Does it matter that they're not the same length? No. Okay, they're parallel. They run alongside of each other. They will never intersect. That makes them parallel. So these two are parallel. What else? I heard it.
Sermon Drive and Knob Hill Drive.
So first off, he said Rockland. Is that what you're saying? This one? This one? This one? Yeah. These two are parallel.
Ain't got a name on it.
It doesn't have that doesn't mean it's not named. It just means Google Map. The long one, Cahoon?
Yeah, Cahoon, and then you're in the way. I'm sorry, I didn't mean that.
Excuse me, Mrs. Marshall. Guys, I teach my 3-year-old manners. I mean, at least. Josh.
going down English Street.
I see it. I don't know what that's called either, but I agree.
Okay, so I don't know what I say.
No, okay, stop.
I cannot.
Stop.
No,
We're just going to
no.
go back to English. Okay, when a K and an N are together. Like, y'all remember that's my son's name with a K and an N. I'm just throwing it out there.
It's the one right here in my.
I know, it's Knob, but okay. And all of them, really.
Oh, we were saying knob.
Yes, that is what I was helping you.
I changed to Ingram Street.
Help me help. No, let me help you. Yeah. What do you say?
I-10 in Ingram Street.
I-10. Well, I-10 and Ingram intersect. I-10 and in Ingram right there.
Yeah.
Sorry, duh. And Ingram right here. Perfect. Those are all parallel. The two on the bottom. Oh, these two?
No.
Well, they are parallel. Millison?
I'm talking about
Is that where you live?
I live right down yonder to the left a little bit more.
Yeah. I live like around
the other way. Where's the 130?
This?
Yeah,
Well, that and the ones below it.
Emily's one. So I live just like a
This
half
one and the
mile
ones below it?
down.
Yeah, if they were straight. So, why aren't some of these straight? What do you think? What would make a builder not make the road straight?
House.
Trees, houses that are already built. What else?
Pipelines that are run underground.
Sure.
No,
There's also like water, right? There's water to account
septic
for.
tanks.
And
What?
yes. Okay. Next, we're going to talk about perpendicular lines. So, this part of the lesson drives me nuts because there are two parts to the definition. Listen, it's very short of a definition. And for some reason, students only remember the first part. But they don't remember the most important part. I don't know why. So you ready? Perpendicular lines intersect and form 90 degrees. So that's what I want you to write. They intersect and form 90 degrees. What part am I shouting to the rooftops?
90 degrees.
And form 90 degrees. So, the reason I'm struggling with students today is these intersect, correct?
Yes.
Do they form 90 degrees?
No.
Are they perpendicular? No, because they don't form 90 degrees. Remember that 90 degrees looks like a corner. None of these look like a perfect corner. This one's way skinnier than 90, this one's way larger than 90. So, perpendicular, they intersect and form 90 degrees. That is what makes them perpendicular. Okay, so what you're going to notice is it says symbol for perpendicular. It is an upside down T. Try to draw it better than me. Upside down T. It's a straight line with another straight line coming out of it. That means perpendicular. It also looks like a thumbtack. Let me see a thumbtack. No? Okay. You can figure out what it looks like for your own. This is the symbol. And then if you were to notate it, which I want you to on your notes, you would write line M is perpendicular to line N. Line M is perpendicular to line N. Line Marshall is perpendicular to line. And then if you have a last name with an N. Natalie. Yep. Line M. Her sister's name's Natalie. It's okay. Okay, and then the key fact you can write down, and then I'll explain it. 4 right angles are formed. 4 right angles are formed. So if you look at this picture, we've got 2 lines that intersect and they keep on going. So all of these are right angles, and here's why. What relationship does this angle have with the angle across from it? What are they called? They're called vertical angles, and what do you know about the measures of vertical angles? They're congruent. So if this is 90, that means this is also 90. Okay? Then, think about this. What do we call the angles that share a wall? They're right next to each other. Well, they're a linear. They are adjacent, but they're a linear pair, these two. We all see it? How many degrees do a linear pair add up to?
180.
180. What is 180 minus 90?
9.
90. So this is 90. Then remember vertical. If this one's 90, what's the measure of this one? 90. So then look, they're all 4 right angles. A good way to check yourself is how many degrees is a 360. What is 90 times 4? 360. So that's where that comes from. The only thing I want to just clarify, in real life, do lines go forever and ever and ever? No. So, yes, it would look like this in geometry. It can also look like let me see if I can do it for this class, 2 segments coming together and forming 90. They are perpendicular to each other. These lines don't have to continue through and intersect. So here's what that means. Not intersect. They don't have to keep on going. Y'all see how these keep on going? Okay. So here's what I mean. In real life, so look at my board, okay? I've got a vertical line, and then I've got a horizontal line. They are perpendicular to each other because they form a right angle. Okay, so a lot of things in life are perpendicular. The corners of doorways, you've got the vertical line going up the doorway, the horizontal line going across the doorway. That makes them perpendicular because they intersect at this point, and this is a 90-degree angle. So that's perpendicular. Okay? We're going to use this word. I would highlight it again because this is important. Parallel and perpendicular are super important for geometry, this section, and in general. We're going to use the same map to find some perpendicular lines. So remember, I'm going to do one. Remember that perpendicular lines intersect and form 90. The one I'm hearing the most, I keep hearing students say these two, but do these two look like they form 90 degrees? No. So that's not one. You said Cahoon and what? Both of them. You're both correct. Cahoon and Ramona, they form 90. Cahoon and Gordine also form 90. You're both correct. Cahoon and like all of these up here, right? So like there's a lot of intersecting and forming 90 up there. You said Cassett. Where is Cassett? Over here? No, I'm not right. Cassett would not be in this picture.
Cassie. Unless I'm reading.
Cassie?
Yeah.
Oh, Cassie. Okay. You're saying these? They might a little bit. It might be a little off.
Oh, whatever that is.
Ramona and
Gordine and Ingram Street. Well, not Ingram
We
Street.
already
I'm
had that.
But that street. No, we didn't do this one.
Oh, what's that one?
These are all intersecting. Which one?
Nelson right over Spring.
Gardenia.
Okay, pause. Michael, what are you saying?
Gardenia, and then that one that starts with B. Right below.
Oh, Burma?
Yeah.
So, Gordine is this one, though, and Burma's. Or is this Burma?
That's the one going up.
I don't know. You're saying this one and Burma.
Right.
You're correct. But I don't know if that's, I don't know what that's called.
Memorial Road. And
We haven't heard even the biggest one yet.
Memorial Road.
I-10
and Ramona.
Thank you. We'll do that one first. I-10 and 295. Fun,
Technically, you can't do
fun
that.
fact in life. Not fun. It's just helpful. Every even numbered highway, it goes east and west. And every odd number highway goes north and south. The reason that I say that is if you look at a compass, because I can talk, they north, south, and east and west are perpendicular to each other. So where these two highways intersect, they're perpendicular on the road. These two are not, though. These are the off-ramps for I-10 on Hammond, just so you know. Do we have another one? You said what? Oh, I-10 and Cahoon. I agree. Here's Cahoon. If I could draw a straight line. There you go. There's a lot over here, too, like with Memorial Park. All of these are perpendicular to Memorial Park. Perfect. That's perpendicular. The last one we talk about together are skew lines. They're the weirdest ones. So think of skew, they're like, ew, they have nothing in common. Skew, they do not intersect and they are non-coplanar. So they do not intersect and they are non-coplanar. They do not intersect, and they are non-coplanar. Do not intersect, and they are non-coplanar. So skew is one of the words on your scrapbook. If you look at our picture, we've got the bright green lines. They're not on the same plane. So if you look, the green is on the ground. So it's like one plane, the road. And then the top one is like on the bridge, right? So they are not on the same plane, and they would never intersect. So even if these lines infinitely went in both directions, they would never intersect. Even if they looped all the way around the road, they wouldn't touch.
So what's the point?
So, I don't know what you mean. What's the point of skew lines? There has to be a word for if they're not intersecting, they're not parallel, they're not perpendicular, then what are they? They're skew.
So you're saying it'll be a question like asking if these are like what are these lines?
Yes. And you have to have one of them. All right, but you have a cube. Two lines are skew if they don't intersect or they're not on the same plane. So here's what you're going to do. We are going to, as a class, pick one line. Sure, FG is what we were told. FG. So go ahead and write it down. We're going to find what is skew to FG. It's in the bottom right-hand corner of our box.
AB.
I'm working on it. Here's a way to find it. If you're having trouble, we need a line that is not coplanar with FG. So what is helpful is to know what is coplanar with FG. So FG is on the bottom of the box. So all of the lines I just outlined are on the same plane as FG. So none of them are skew. FG is also a part of the side of the box, right? So it's also on this plane. So none of the lines I highlighted in red could be skew because they're on the same plane as FG. So now, so they said A, did you say B or D? Either one is correct, actually. So AB, you could say AD. Put the word and, sorry. There's no symbol for skew. Parallel, there was a symbol. Perpendicular, there was a symbol. This one, there's not. So you got AB, AD, literally all of the ones that are not outlined. You got DC, what are we missing? AE, and then DH. Any of those would be skew. I just didn't write them all down. So as long as they're not on the same plane and they don't intersect with FG, then they're skew.
Wait, wouldn't B be on the same plane as FG?
I'm talking about the line on the same plane.
Oh, okay.
So AB is not on the same plane. Good question. All right, you can flip. Parallel planes. Parallel planes. So planes are either parallel or intersecting. Those are the only options. So if they're parallel, they are planes that don't intersect. That's what you write in. They're planes that do not intersect. Planes that do not intersect. So in my picture, why did I choose this aesthetically pleasing?
Because they're never going to touch each other.
What are
Rails.
The
stairs.
the steps? So I would say the rails are more like lines, parallel lines. So I see what you're saying. These would be parallel lines. If I could draw a line, then you would see it better. But what we're talking about with planes, it would be the steps are parallel. The tops of them are parallel, and the fronts of them even are parallel to each other. So what you've got is a box. We're going to name two parallel planes. We can name any of them that we want. But before we name a plane, what do we always have to write? The word plane. So let's pick a part of the box. Top, bottom, left, right, top.
Right.
I heard more people say the top of the box. Oh my. So how do we want to name the top of the box?
ADBC.
Okay. Back. When you name a plane, how many letters do you use?
2.
3.
1. 3.
3. When they are points, listen, these are all points. You see how they're red dots? These are all points. When you have points, you use 3 letters. So pick 3 letters.
ADC.
I think you said D. That's fine.
Yeah.
And then you would use the parallel symbol. Parallel So the top of the box is parallel to the bottom of the box. So what do we want to name the bottom of the box?
EHD.
Plain.
Plane, and then I heard HGF first. You wouldn't be wrong though, Josh.
That's what I heard.
Very aggressive. So some of you are getting mixed up with planes. If it has a letter, an uppercase letter with no dot shoved in the corner, this would be plane R. But that's not happening here. These are all points. So if all you have are points on the plane, you name it with 3 points on the plane. Questions, comments, concerns? Okay. We are doing the last question. This is what the assignment looks like. It says, think of each segment in the figure as part of a line. So remember that lines never end. They continue infinitely. So they kind of drew one of them like that, but you want to envision that. The only reason it says it is when you name each of these lines, like A, name a line parallel, we're naming a line with arrows. Okay, so keep that in mind. So we want to name a line that is parallel to CD that contains point A. Here's why it says it like that. Some of these will have a bunch of answers. Think about the skew question we did on the front page. There were a lot of answers. I am one person and I have 100 students. I do not want to grade that many because there are so many answers and you guys are so creative. So when it says through a point, it's just so you're limiting your answer pool. So here we've got CD. We want it to be parallel to point A. It needs to be on the same plane as CD and not intersect with CD. So what line is that going to be? AB. AB. Second part, it says skew containing point A. So remember, skew, they're not on the same plane. They do not intersect. So CD is a part of this plane, and it's also a part of this one. So using point A, what lines do not intersect with CD, and they're not on the same plane as CD? AH, that's one.
J. G.
AH and AG. So remember, we want to contain point A. GH is skew, but it doesn't have point A. So AHAG. Now, I'm not saying the other ones were wrong. They just didn't have point A. So they were wrong. All right, and then letter C, it says a plane that is perpendicular, a line that is perpendicular. So perpendicular means they intersect and do what? They form 90. So what line will intersect with CD that contains point A? AD or DA, same thing. AD or DA, either way. So I want you to pause for a second. If you look, there were right angles drawn here, but this is a box. Normally a box won't have right angles drawn, but in order for a box, like think a moving box or a cube or something, in order for it to form or close, they have to be right angles or it wouldn't be made properly. If you've ever built anything like that, I know that you guys are obviously like 15, 16, so maybe you haven't, you probably haven't. But it's assumed that if it's a cube or like a rectangular prism, like your homework, it's a fish tank. In order for it to close, they have to be right angles. So they're not going to have right angles drawn. They might have it stated in the directions, but if it's a cube, you can assume that they're right angles or it wouldn't be a cube. Do you kind of understand what I'm saying? If you ever put together a moving box or like, they got to be right angles. So starting out there. Here they were drawn, but on a cube it won't be drawn. Like the one at the top of the page. So everyone look at the one at the top of the page. They aren't drawn, but it's understood that if it's a square like that, those are right angles. Okay. Last one. Find a plane that is parallel to EFG. So that is this bottom plane. So no matter what our answer is, it's got to have the word plane. And it needs to contain point A. Sure. DAB, ABC, BAC, you get it. Cab, whatnot. Okay.